Today I'll be just teaching you about how to plot the VI characteristics of a Zener diode, or the other way around, that how the Zener diode acts as a voltage regulator. So the circuit diagram is already there with you, and we all know that what is special about the Zener diode is that it is a heavily doped diode. Both P and N sides are heavily doped, and it is used for the high voltage or the high field applications, so that even if there is a change in the current, there is no change in the voltage. So let's just go to drawing the circuit, and uh, and we need to remember that the Zener diode is always operated in the reverse. When it is forward biased, it will operate as a normal diode. Okay, so I've just made this circuit. I can make it again. So, this is the DC source, which is V1 here. The value is 10 volts I've kept. R1 is 2 kilo ohms. A meter is there to measure the current. There's a voltage probe to measure the Zener voltage. We can just rename it as VD, or we can just rename it as, instead of VD, we can rename it as VZ. That is the Zener voltage. And we are placing a ground over here. Okay, now before we okay, once we've made the circuit, we'll go to the save part of the circuit. We will save it, and then in the simulation settings we will see what are the settings which we have kept there. So many of the students have been complaining me that they are not able to run their simulations because of the fact that the transient simulation settings are not correct in their programs. So what we need to do is, like, the first one, which is the maximum time step, it's one 1 microsecond. Stop time has to be 1 minute. That is, the simulation will run for 1 minute, and the start time has to be 0. So then you'll get dot trans, because trans gives the transient simulation, because your simulation will run for some time. Then AC analysis, you don't have to do AC analysis. Okay, even if, okay, we do not need to do the AC analysis, but type of speed we will keep it as decade, because it will show us the current in the logarithmic scale. We can keep it as linear as well. So then we have the DC sweep. DC sweep we need to keep here, because what we are doing here is we are sweeping this input voltage, and that is why I am writing here. I'll write source to sweep is actually, it is V1. What is the start value? Start value, I'll keep it as 0. Stop value, I'll keep it as, for example, first I'll keep it as 1, and then increment, I'll give it a step of 0.05. Okay, so now you'll automatically see that we'll get the, okay, so here is the graph. Like, okay, let's just forget about this, the voltage. We can see that the current here, it rises. It is actually saturating over here, because the orange one is the the orange one is the current, and blue one is the voltage. So it's a normal diode. Now when we have to operate it as a voltage regulator, although we have put up the value of the DC voltage source, input DC voltage source, as 10, but in our simulations we have not put up the value as 10. We'll again go to the simulation setting. Instead, stop value is 1, we will take it as 10, and the increment will be again 0.05, or we can just increase it to 0.5. Why to keep it as, or else we'll just double it and keep it as 0.1, and then run it. You will automatically see that this is going to change here, and here is your graph. All right, so this is the voltage and this one is the current. So you can see now the current is like kind of 0 before, and then when the voltage is reached around, it's 9 volts or 9.1 volts, the current rises abruptly. So the value of the Zener voltage is 9.1 volts here. So this is how the Zener graph has to be, the VI characteristics or have to be plotted for a Zener diode as well. Or if we need to show that how the Zener diode acts as a voltage regulator, we can even check it there. I guess the screen might not be visible. I'll just change the screen. Yeah. So now I have reduced my window and you can see the graph. So it is just the Zener characteristic. So this point where your current is increasing vertically almost and the voltage is remaining the constant, this is the value of the Zener voltage. I hope you'll be able to do it, and wherever you are facing any problem, you may just drop me a message and you can check it here. I have just said that for the simulations, go to the simulation settings, go to transient. So maximum step it's 1U, then 1M, and then 0, and then run your simulations, and you'll be able to do it.